Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question, question number 2 of NEET 2014 physics paper. Students, let us solve the next question of physics paper, question number 2 of NEET paper. A projectile is fired from the surface of a planet Earth with a velocity 5 meters per second and angle theta with horizontal. So this is Earth and a projectile is fired with a velocity of 5 meters per second with an angle theta with the horizontal. So obviously it will go and fall like that, some path like this. This is the trajectory of this projectile. Somewhere it will land here, suppose. Another projectile fired from another planet. So say this is another planet. Suppose the planet is X, planet X, with a velocity, now the velocity is 3 meters per second. At the same angle, so angle is same, follows the trajectory which is identical with the trajectory of the projectile fired from the Earth. Means whatever trajectory it follows, this is the trajectory here and this is the trajectory there. It says that both the trajectories are identical. So trajectory being identical means that the range over here, suppose it is R1, the range from here to here. So here the range is, suppose here to here it is R2. So trajectory similar. This implies that the range will be same for Earth and the planet X. The range in both the cases will be same because they have to follow the same trajectory, so they will land at the same point. So the distance from the point of projection and the point where it lands must be same in both the cases. This is the conclusion that you can draw from here. The value of the acceleration due to gravity on the planet is given by. So to find the in this planet, what is the acceleration due to gravity? In this case, the acceleration due to gravity in this planet Earth is 9.8 given. What is the value of g on this planet X that you have to find? So we have this equation. We'll write the formula for range and we'll equate it. There is one equation and one unknown, and the unknown is gx. Then you can find it out. This is so simple question. Range formula for a projectile is u square sine 2 theta upon g. So I'll write in this next space the range formula for a projectile. You must have known that the range of the projectile is u square sine 2 theta over g, where u is the velocity of projection and theta is the angle of projection. R1 being equal to R2, so it is 5 square because initially it was fired at 5. So initial velocity here is 5. Sine 2 theta, because theta is same in both cases, and g of Earth here 3 square because it's fired in the with the velocity 3 meters per second from next planet, the other planet. So u square sine 2 theta, this will remain the same, divided by g, g of the planet X. This is given 9.8. This sine 2 theta, theta being same, so this will cancel out. This will cancel out. Gx is required, so Gx will be 3 square divided by 5 square into g of e. Multiply this there. This is 9 divided by 25 into 9.8 meter per second square. After solving this, we'll get the answer, but then I'll just use the concept that I'll consider this as 10 for easier calculations. You can also solve this before actually going for the calculations, because that will waste your time. So just take it 10 and see the options which is nearby that. If I take 10 and whatever I get, then the actual value is little less than that. So I'll take 10. So this will become 9 into 10 divided by 25. So 25 I'll write 4 here and 4 multiply there. This is 100. So this is 100. So this is 10. So 36 divided by 10. So it is 3.5. Sorry, 3.6. 3.6. So I'm getting 3.6 meter per second square, because that will reduce my time of calculation, that I'm not actually going for 9 into 9.8. That will take time. So I'm getting 3.6, but actual answer should be less than 3.6, little less than that. If I go for little less than that, so then this is the only one which is matching. This is 3.5. Others are, you can see, 3, 5 point, 16 point, 110. It will never match. This is more accurate. So this way you can save your time by going for a little more or little less number, and you can check the answer. Okay. So this is the answer to this question. It was a very simple question, and the answer is option number 1. Okay. Thank you.